Namaste and a warm greeting to everyone present here. We are awaiting the arrival of our chief guest. We'll begin the program shortly. Requesting you all to put your mobile phones on silent mode and request all the students to remain seated. In a few moments, we will begin today's special lecture on India's space missions by Dr. S. Somanath. To set the stage for this momentous occasion, we present before you a video clip on India's tryst with the moon, that elusive magical entity that has enamored and intrigued us from afar for ages, but no longer beyond our limits. So let's watch this video as a prelude to the wonderful moments that await us in the afternoon.
How many of us have wished upon the distant glowing sphere, hoping one day to hold its light in their own hands? But beyond wishes and wonder, the moon also sparked a deeper question in the human mind. Could there be a home beyond Earth? As our minds expanded beyond the horizon of our planet, the moon became humanity's first imagined outpost. It was our stepping stone to the stars, the nearest neighbor in the vast universe. Then, in 1969, humanity's dreams took a giant leap. Neil Armstrong set foot on the moon, leaving an imprint that symbolized humanity's entry into the universe. His words, "One small step for man, one giant leap for mankind," echoed across the globe, stirring aspirations in every corner of the earth, including India. His steps on the lunar soil were more than just an achievement. They were an invitation for others to explore, to dream, and to reach for the stars. And here in India, the moon was not only a distant figure of inspiration, but a calling to rise. That call was answered by ISRO, the Indian Space Research Organization. With each mission, ISRO sought to bring India closer to the stars, and in doing so, it inspired a nation to look beyond its borders and towards the infinite. The journey began with Chandrayaan 1 in 2008, India's first bold step towards the moon. The mission brought us closer to the mysteries of our lunar neighbor, discovering traces of water on its surface, a revelation that forever changed our understanding of the moon and its potential. And ISRO's ambition did not end there. In 2019, Chandrayaan 2 advanced our mission, venturing toward the uncharted lunar South Pole. Though the lander's descent didn't unfold as planned, the mission was a testament to India's spirit of exploration, learning, and resilience. Then came Chandrayaan 3, an awe inspiring success that fulfilled a dream shared by millions. On August 23, 2023, India made history by becoming the first country to land on the moon's south pole, a region where no other country had ventured. ISRO's Chandrayaan missions have not only marked India's place in the annals of space exploration, but have also fulfilled a dream long held in the hearts of every Indian. From the child in their mother's arms to the scientists gazing up at the night sky, the moon now bears the footprints of our aspirations, a symbol of how far determination and unity can take us. In 1985, After joining ISRO at the Vikram Sarabhai Space Center, Dr. Somanath continued to advance his studies and expertise, embodying a dedication to lifelong learning. His journey is an inspiration to all those who may pause their pursuit of knowledge upon entering the workforce. From the small hamlet Thuravur in Alapura to the lead position as a chairman of ISRO, one of the highest positions in the Indian space exploration, Dr. Somanath's achievements underscore that it is but the hard work and dedication that determine success. All throughout his career, he has made significant contributions to numerous high profile missions and advanced projects within ISRO. A milestone achievement, the development of the GSLV Mk3, India's most powerful rocket, enabling the nation to launch heavy satellites and conduct ambitious space missions, to being the director of VSSC and later director of the Liquid Propulsion Systems Center, and then to the role of chairman of ISRO. His journey exemplifies how commitment, perseverance, and a thirst for knowledge can lead to remarkable achievements, inspiring future generations to reach for the stars. It is indeed our privilege today to share this space with a beacon of knowledge, path breaking scientist, determined and focused noble soul, Kerala's personal pride, Dr. S. Somanath. How many of us have wished upon the distant glowing sphere, hoping one day to hold its light in their own hands? But beyond wishes and wonder, the moon also sparked a deeper question in the human mind. Could there be a home beyond Earth? As our minds expanded beyond the horizon of our planet, the moon became humanity's first imagined outpost. It was our stepping stone to the stars, the nearest neighbor in the vast universe. Then, in 1969, humanity's dreams took a giant leap. Neil Armstrong set foot on the moon, leaving an imprint that symbolized humanity's entry into the universe. His words, "One small step for man, one giant leap for mankind," echoed across the globe, stirring aspirations in every corner of the earth, including India. His steps on the lunar soil were more than just an achievement. They were an invitation for others to explore, to dream, and to reach for the stars. And here in India, the moon was not only a distant figure of inspiration, but a calling to rise. That call was answered by ISRO, the Indian Space Research Organization. With each mission, ISRO sought to bring India closer to the stars, and in doing so, it inspired a nation to look beyond its borders and towards the infinite. The journey began with Chandrayaan 1 in 2008, India's first bold step towards the moon. The mission brought us closer to the mysteries of our lunar neighbor, discovering traces of water on its surface, a revelation that forever changed our understanding of the moon and its potential. And ISRO's ambition did not end there. In 2019, Chandrayaan 2 advanced our mission, venturing toward the uncharted lunar South Pole. Though the lander's descent didn't unfold as planned, the mission was a testament to India's spirit of exploration, learning, and resilience. Then came Chandrayaan 3, an awe inspiring success that fulfilled a dream shared by millions. On August 23rd, 2023, India made history by becoming the first country to land on the moon's south pole, a region where no other country had ventured. ISRO's Chandrayaan missions have not only marked India's place in the annals of space exploration, but have also fulfilled a dream long held in the hearts of every Indian. From the child in their mother's arms to the scientists gazing up at the night sky, the moon now bears the footprints of our aspirations. a symbol of how far determination and unity can take us. In 1985, after joining ISRO at the Vikram Sarabhai Space Center, Dr. Somanath continued to advance his studies and expertise, embodying a dedication to lifelong learning. His journey is an inspiration to all those who may pause their pursuit of knowledge upon entering the workforce. From the small hamlet Thuravur in Alapura to the lead position as a chairman of ISRO, one of the highest positions in the Indian space exploration, Dr. Somanath's achievements underscore that it is but the hard work and dedication that determine success. All throughout his career, he has made significant contributions to numerous high profile missions and advanced projects within ISRO. A milestone achievement, the development of the GSLV Mk3, India's most powerful rocket, enabling the nation to launch heavy satellites and conduct ambitious space missions, to being the director of VSSC and later director of the Liquid Propulsion Systems Center, and then to the role of chairman of ISRO. His journey exemplifies how commitment, perseverance, and a thirst for knowledge can lead to remarkable achievements, inspiring future generations to reach for the stars. It is indeed our privilege today to share this space with a beacon of knowledge, path breaking scientist, determined and focused noble soul, Kerala's personal pride, Dr. S. Somanath. How many of us have wished upon the distant glowing sphere, hoping one day to hold its light in their own hands? But beyond wishes and wonder, the moon also sparked a deeper question in the human mind. Could there be a home beyond Earth? As our minds expanded beyond the horizon of our planet, the moon became humanity's first imagined outpost. It was our stepping stone to the stars, the nearest neighbor in the vast universe. Then, in 1969, humanity's dreams took a giant leap. Neil Armstrong set foot on the moon, leaving an imprint that symbolized humanity's entry into the universe. His words, "One small step for man, one giant leap for mankind," echoed across the globe, stirring aspirations in every corner of the earth, including India. His steps on the lunar soil were more than just an achievement. They were an invitation for others to explore, to dream, and to reach for the stars. And here in India, the moon was not only a distant figure of inspiration, but a calling to rise. That call was answered by ISRO, the Indian Space Research Organization. With each mission, ISRO sought to bring India closer to the stars, and in doing so, it inspired a nation to look beyond its borders and towards the infinite. The journey began with Chandrayaan 1 in 2008, India's first bold step towards the moon. The mission brought us closer to the mysteries of our lunar neighbor, discovering traces of water on its surface, a revelation that forever changed our understanding of the moon and its potential. And ISRO's ambition did not end there. In 2019, Chandrayaan 2 advanced our mission, venturing toward the uncharted lunar South Pole. Though the lander's descent didn't unfold as planned, the mission was a testament to India's spirit of exploration, learning, and resilience. Then came Chandrayaan 3, an awe inspiring success that fulfilled a dream shared by millions. On August 23rd, 2023, India made history by becoming the first country to land on the moon's south pole, a region where no other country had ventured. ISRO's Chandrayaan missions have not only marked India's place in the annals of space exploration, but have also fulfilled a dream long held in the hearts of every Indian. From the child in their mother's arms to the scientists gazing up at the night sky, the moon now bears the footprints of our aspirations, a symbol of how far determination and unity can take us. In 1985, after joining ISRO at the Vikram Sarabhai Space Center, Dr. Somanath continued to advance his studies and expertise, embodying a dedication to lifelong learning. His journey is an inspiration to all those who may pause their pursuit of knowledge upon entering the workforce. From the small hamlet Thuravur in Alapura to the lead position as a chairman of ISRO, one of the highest positions in the Indian space exploration, Dr. Somanath's achievements underscore that it is but the hard work and dedication that determine success. All throughout his career, he has made significant contributions to numerous high profile missions and advanced projects within ISRO. A milestone achievement, the development of the GSLV Mk3, India's most powerful rocket, enabling the nation to launch heavy satellites and conduct ambitious space missions, to being the director of VSSC and later director of the Liquid Propulsion System Center, and then to the role of chairman of ISRO. His journey exemplifies how commitment, perseverance, and a thirst for knowledge can lead to remarkable achievements, inspiring future generations to reach for the stars. It is indeed our privilege today to share this space with a beacon of knowledge, path breaking scientist, determined and focused noble soul, Kerala's personal pride, Dr. S. Somanath. How many of us have wished upon the distant glowing sphere, hoping one day to hold its light in their own hands? But beyond wishes and wonder, the moon also sparked a deeper question in the human mind. Could there be a home beyond Earth? As our minds expanded beyond the horizon of our planet, the moon became humanity's first imagined outpost. It was our stepping stone to the stars, the nearest neighbor in the vast universe. Then, in 1969, humanity's dreams took a giant leap. Neil Armstrong set foot on the moon, leaving an imprint that symbolized humanity's entry into the universe. His words, "One small step for man, one giant leap for mankind," echoed across the globe, stirring aspirations in every corner of the earth, including India. His steps on the lunar soil were more than just an achievement. They were an invitation for others to explore, to dream, and to reach for the stars. And here in India, the moon was not only a distant figure of inspiration, but a calling to rise. That call was answered by ISRO, the Indian Space Research Organization. With each mission, ISRO sought to bring India closer to the stars, and in doing so, it inspired a nation to look beyond its borders and towards the infinite. The journey began with Chandrayaan 1 in 2008, India's first bold step towards the moon. The mission brought us closer to the mysteries of our lunar neighbor, discovering traces of water on its surface, a revelation that forever changed our understanding of the moon and its potential. And ISRO's ambition did not end there. In 2019, Chandrayaan 2 advanced our mission, venturing toward the uncharted lunar South Pole. Though the lander's descent didn't unfold as planned, the mission was a testament to India's spirit of exploration, learning, and resilience. Then came Chandrayaan 3, an awe inspiring success that fulfilled a dream shared by millions. On August 23rd, 2023, India made history by becoming the first country to land on the moon's south pole, a region where no other country had ventured. ISRO's Chandrayaan missions have not only marked India's place in the annals of space exploration, but have also fulfilled a dream long held in the hearts of every Indian. From the child in their mother's arms to the scientists gazing up at the night sky, the moon now bears the footprints of our aspirations, a symbol of how far determination and unity can take us. In 1985, after joining ISRO at the Vikram Sarabhai Space Center, Dr. Somanath continued to advance his studies and expertise, embodying a dedication to lifelong learning. His journey is an inspiration to all those who may pause their pursuit of knowledge upon entering the workforce. From the small hamlet Thuravur in Alapura to the lead position as a chairman of ISRO, one of the highest positions in the Indian space exploration, Dr. Somanath's achievements underscore that it is but the hard work and dedication that determine success. All throughout his career, he has made significant contributions to numerous high profile missions and advanced projects within ISRO. A milestone achievement, the development of the GSLV Mk3, India's most powerful rocket, enabling the nation to launch heavy satellites and conduct ambitious space missions, to being the director of VSSC and later director of the Liquid Propulsion Systems Center, and then to the role of chairman of ISRO. His journey exemplifies how commitment, perseverance, and a thirst for knowledge can lead to remarkable achievements, inspiring future generations to reach for the stars. It is indeed our privilege today to share this space with a beacon of knowledge, path breaking scientist, determined and focused noble soul, Kerala's personal pride, Dr. S. Somanath.
Thank you, Team Erur, for taking us through that amazing journey of ISRO and Dr. S. Somanath's contribution towards his successful journey. It was indeed a beautiful prelude to the wonderful lecture that we are going to witness today. Our chief guest will join us in a short while. Requesting everyone to remain seated. Once again, reminding you to put your mobile phones on silent mode. Thank you. Our chief guests and other dignitaries have arrived. Let's rise and extend a standing ovation and welcome to our distinguished chief guest, Dr. S. Somanath, Chairman, Indian Space Research Organization. He is now being graciously escorted into the auditorium by our chairman and other dignitaries of the Kendra. I invite our distinguished chief guest, Dr. S. Somanath, our chairman, C.A. Venugopal C. Govind, vice chairman, Professor Dr. Ambat Vijaykumar, director, Sri Ramankuti, honorary secretary, C.A. K. Shankaranarayanan, chief coordinator programs, Srimati Meena Vishwanathan, to occupy their seats on the dais. Honorable Chief Guest, Dr. S. Somanath, esteemed members of the management, distinguished dignitaries, invited guests, well-wishers, teachers, and dear students, Namaste and a pleasant afternoon to you all. Since its humble beginnings in 1969, ISRO has evolved into a powerhouse of technological innovation and discovery, breaking boundaries and setting new benchmarks in space exploration. Most recently, ISRO's successful Chandrayaan-3 mission has drawn the world's attention to India's capability to explore the moon's south pole, a challenging and scientifically significant region. It is an exceedingly proud day for all of us as we gather here today to lend our eager ears to Dr. S. Somanath, Chairman ISRO, Secretary Department of Space, and Chairman Space Commission, who is here to deliver the special lecture on India's space missions. Without further ado, let's commence our program by invoking the blessings and benevolence of the Almighty. The students of Bhavan's Varuna Vidyalaya will now lead us in prayer. I request everyone to remain seated as we immerse ourselves in this spiritual chant.
Vande Shambhumumapatim Suragurum Vande Jagatkaranam Vande Pannagabhushanam Mrigadharam Vande Pashunapatim Vande Surya Shashanga Vanninayanam Vande Mukunda Priyam Vande Bhakta Janashrayam Chavaradam Vande Shivam Shankaram Vande Shivam Shankaram Vande Shivam Shankaram Loka samasta Sukhino bhavantu Loka samasta Sukhino bhavantu Loka samasta Sukhino bhavantu.
May I now invite Shri Ramankuti, Director Bharati Vidya Bhavan Kochi Kendra, to accord a formal welcome to all who have honored us with their presence today.
Namaste and good afternoon to everyone. Distinguished guest of the day, Dr. Somanath, revered Chairman, esteemed Managing Committee members, special invitees, faculty members, and dear students. It is truly an honor to stand before you today as we gather for this special lecture on India's space missions. We are here to celebrate the inspiring achievements of our nation in space exploration and to gain insights from a visionary who has guided many of these remarkable journeys. I am thrilled to welcome our distinguished guest and speaker of the day, Dr. Somanath, Chairman of the Indian Space Research Organization, Secretary of the Department of Space, and Chairman of the Space Commission. Under Dr. Somanath's visionary leadership, ISRO has reached new frontiers, including the successful landing of Chandrayaan-3, which captivated millions and highlighted India's capabilities on the world stage. Sir, we deem it an honor to listen to you at closer quarters, and with open hearts, we welcome you, sir. A very cordial welcome to our chairman, C.A. Venugopal C. Govind, whose unwavering support and guidance have propelled our institution towards excellence. His vision and dedication to uphold our values and standards of Indian education have been instrumental in shaping the Bhavan's legacy. A hearty welcome to you, sir. I would also like to extend a warm welcome to Professor Ambad Vijayakumar, our esteemed Vice Chairman, who has always been a pillar of support in bringing enriching programs to our institution. A warm welcome to you, sir. We are indeed fortunate to have with us C.A. K. Shankaranarayanan, Honorary Secretary Bharati Vidya Bhavan Kochi Kendra, whose dedication and contributions to the Bhavan are deeply appreciated. Welcome, sir. A very cordial welcome to Srimati Meena Vishwanathan, Chief Coordinator, Programs. Madam, your tireless efforts in organizing and coordinating such impactful events ensure that each program runs seamlessly and meaningfully. I extend a warm welcome to you, ma'am. Joining us today are our Vice Chairman, C.A. G. Gopinathan, Honorary Treasurer, C.A. K.T. Mohanan, and other distinguished members of our Managing Committee whose unwavering commitment has made today's event possible. We are grateful for their guidance, which continuously enhances our educational experience. A hearty welcome to you all. To all the parents, faculty members, and students from Bhavans and beyond, welcome to an event that promises to be both enlightening and inspiring. Today, you will have the unique opportunity to learn firsthand from one of the most respected figures in Indian space science, a rare and invaluable experience. I encourage each of you to engage deeply, win answers to your doubts, and to let today's session fuel your aspirations. Once again, I welcome all our dignitaries, guests, faculty, and students to this special event. Let us now immerse ourselves in the knowledge and inspiration that Dr. Somanath will share, and guides us through India's extraordinary achievements in space. Thank you.
Thank you, sir, for your gracious words of welcome. It is now my distinct privilege to invite our esteemed chairman, C.A. Venugopal C. Govind, to deliver the presidential address.
Namaste. Namaste to all of you. Good afternoon. Our honored Chief guest, Dr. Somanath, distinguished director of NPOL, Dr. Duveri Sheshagiri, his colleagues, all the distinguished guests, invitees who have been so good enough to be here with us on an afternoon like this, my esteemed colleagues in the managing committee, distinguished educationists, principals, vice principals, teachers, my dear students. This is a very, very significant day for all of us. Very important to be written in red letter in the annals of history of the Kochi Kendra of Bharatiya Vidya Bhavan. Because we are celebrating many things today. It's a day of celebration. We have with us none other than the chairman of the ISRO. ISRO means many, many things to the nation. ISRO means many things to every Indian. ISRO means a lot to the galaxy of science teachers and the senior science students from all our schools present here. It's a very rare occasion that we have the head of the ISRO to share some of the very important aspects concerning the planning, the vision, the zeal, the modalities, the processes, the failures and the success, enduring success, eternal lasting success which they have by now achieved in the field of space research. India has been on the forefront in many things globally. 300 years ago, 400 years ago, forefront in science, literature, mathematics, astronomy, astrology, you name it. There were no one to match us. When the whole world was moving around like barbarians, we were highly educated, knowledgeable, profound wisdom, treasure trove of knowledge and wisdom. Even today, is a moiety which has not been unleashed or touched, existed in this country. But then hundreds of years of slavery, foreign rule, practically brought us to feel ourselves that we are a non-entity in the world. ISRO has lit the light and shown the way. The most outstanding success in any field which has been achieved in India, the topmost at the zenith is undoubtedly the space research. There's no doubt about that. Absolutely no doubt about that. So we are celebrating the success of the space research of India today. To be informed, to know that India is the first country in the world to send a spacecraft, a lander to land on the south pole of the moon, the only nation so far to achieve that, and we are the first to achieve, is something really unimaginable. We are therefore celebrating the success of our nation in that area. But we are aware how this has been achieved. Many, many, many young minds, scientists who are involved in that, brains. India has produced such a lot of very significant men of knowledge, wisdom, and they have all contributed incessantly over decades to attainment of this very stellar accomplishment for our nation. We also have had failure, no doubt. 2 days are very important for us. When we have the chairman with us, we remember 2 days. 7th of September 2019, when most of us, including our Prime Minister, was watching with awe the landing of Chandrayaan-2. It had achieved almost 99% success. We saw that. Just 2 seconds before landing, it was lost. Communication was lost, and Chandrayaan-2 crashed. We all felt, Prime Minister himself felt, would have felt very bad about that. But then Prime Minister had the peace of mind, the serenity, the tranquility, the equanimity, the equilibrium to console the most deserving man for all the success it had reached until that 2 seconds before landing, Dr. Soman. consoled him and said, don't worry, you have achieved tremendous amount of success. We have landed. In fact, I was told, we have landed on the South Pole, but it crashed only. We landed anyway. The lander has landed there. But it was not the success that we were all looking for. It took 4 years for us to reach the South Pole as we wanted. That day, still again, we all remember 23rd of August 2023, the moments we live. Many times we have lived all over. How so meticulously planned Chandrayaan 3 landed, you see, right on the spot. The lander landed. The lander got out of the orbiter. The lander carrying the rover landed there. And it opened and the rover came out and went around. See. The Chandrayaan 2 also, the orbiter, the lander had got out of the orbiter and started orbiting. But unfortunately, at that point, the lander got out of the orbiter but could not land. And many, many successes followed also. We cannot forget that within 10 days of that, Aditya L1 landed. Aditya L1 mission, you see, to reach the solar, the spacecraft, which is something, it must have also been planned and launched many, many days ago, perhaps, to reach up to the sun, to inquire into the chromosphere and coronal atmospheric aspects of sun, and to study that it has been placed at the right place at the orbit, as they say, in the L1, as they say, Lagrange 1 point between the earth and the sun, it was placed, and that was a huge success. So all these success in the space mission, and in 2026, we are told that another very major mission will take place. Chandrayaan 4 will be launched. 2027, Chandrayaan 4 will be launched, and it will go and pick up some parts of the particles from the moon. It will be explained to us, and it is going to be another success story. We are competing with China, no doubt about it. We are not far behind China. One great thing is that in every aspect, China has gone far ahead of us, but we are not far behind them. In 2000, recently, I believe they launched what they call the Chang'e 6, which has gone and has started picking up the particles from the far side of the moon. In 2026, they are going to launch the Chandrayaan, the Chang'e 7, as they call that. That is going to do a lot of exploration on the south pole of the moon to find out the icy water and many things which scientists are looking for in that. We are also going to do that in 2027. Maybe an year or two only is the difference between them. But the obvious advantage is the cost. As the finance man, I look at that. The whole world, the United States or Russia or China had spent so many crores on this. China's expenditure on these kinds of missions have been more than double. Whereas you look at that, Chandrayaan 2 cost us a little over 900 crores. Chandrayaan 3 cost us only 600 crores. Aditya 1 cost us about 543 crores only. Chandrayaan 4 is going to cost us 400 crores only. We add it together. As accountants, we can add it in mind and say this is about 2,600 crores. Within that, we have achieved so much of success. 2,600 crores is not a big money for India now. One family is spending 5,000 crores over marriage now. You have seen that. So within that limits, we are going to such great successes we have achieved that. So the lesson now that we have going to learn, mainly this session is designed as an instructional lessons for our science teachers and our science students. You can also look up to the moon. You can look at the sky. Moon and the sky is the limit for you to grow. How science education has to be tempered. What are the limitless barriers of the science education? You will be instigated, you will be stimulated, you will be motivated, you will be inspired by this. The science teachers also have to learn a lot. Dr. Somanath a short while ago shared with us that he didn't want to be an engineer, much less a space scientist. He wanted to take up to biology and become a doctor and all that. Still today he believes he would have shined much more. Then we said, what you felt was your loss in not having gone to medicine is the gain for the nation today. We have such an eminent personality. It's not very easy. Dr. Somanath is an epitome of success. We have seen that all through his modesty, his simplicity, his humility, his mannerism, his scientific temper, approach, his vision. All these are, you see, inexplicable, no doubt about that. Otherwise, that might of a success could not have been achieved. That is why probably he is called Dr. Somanathan. Chandrayaan 2 was headed by Dr. Soman. Chandrayaan 3 by Somanathan. There is some similarity in that. Soman means what? Sanskrit teachers will tell you. Sa umaha. Sa umaha. Sa plus umaha. The one Uma Sahitaha. One who is with Uma. Uma Sahita. Uma Maheshwaraha is Soman. So Soman himself is Uma Sahita. He could land Chandrayaan 2. But Somanathan, it is something above Soman. Somanathan means someone who controls, who has entire aspects under his thumb, and Somanathan may not fail. An astrologer told me Chandrayaan 2 was launched on the 22nd of July 2019. It was a Karkataka month. That was too bad. Whereas Chandrayaan 3 was launched on 14th of July. 14th of July, it was Mithuna. Karkataka has not started. And it landed in Chingam. So therefore, in all respects, Dr. Somanathan stands for success for us, all spheres, and we are all ears to him. Certainly, there will be a lot of takeaways for that, and that is precisely this meeting is organized. I am sure you will go back what you see, what you learn, what you listen to, what you instill in yourself, what you imbibe in yourself, and take it wide to all the students and all the teachers in all our schools. Then our purpose or objective will be achieved. Thank you very much. Once again, Dr. Somanath, I join you in the heartiest congratulations and felicitations to you, the man of the moment. Thank you very much.
Thank you, sir, for your insightful words. This lecture wouldn't have been possible if not for Professor Dr. Ambad Vijay Kumar, Vice Chairman of Bharatiya Vidya Bhavan Kochi Kendra, whose efforts were instrumental in bringing into our midst such an illustrious personality as Dr. S. Somanath. With extreme delight, I now invite Professor Dr. Ambad Vijay Kumar to introduce our renowned speaker. Sir.
Namaste to all of you. Respected President of this meeting, Sri Venugopal C. Govind, Chairman, Bharatiya Vidya Bhavan Kochi Kendra, Chief Guest Dr. Somanath, Chairman ISRO, Director Sri Ramankuti, members on the dais, invited guests, my dear teachers and students. Let me first of all thank Dr. Somanath for accepting our invitation to address a gathering in this prestigious Sardar Patel Sabhagriha. Let me also thank Mr. Sadish, a batchmate of the chief guest in BTech and former Vice President of Carborundum, for connecting us. Dr. Somanath represents a great institution, ISRO, formerly known as Indian National Committee for Space Research in COSPAR, set up in 1962 by the then Prime Minister Jawaharlal Nehru on the recommendation of Dr. Vikram Sarabhai, the father of space programs in India and guru of many space scientists, including Honorable Dr. APJ Abdul Kalam. It was renamed as ISRO in 1969, and Dr. Vikram Sarabhai was its first chairman, followed by a galaxy of visionaries, Dr. M.G.K. Menon, Professor Sadish Dhawan, Professor U.R. Rao, Dr. Kasturi Rangan, Dr. Madhavan Nair, Dr. K. Radhakrishnan, Dr. Kiran Kumar, and Dr. K. Shivan. I was fortunate to have met most of them during their visits to Cochin University. Sir Isaac Newton once famously said, "If I have seen further than others, it is by standing upon the shoulders of giants." In the case of ISRO, in addition to the names mentioned above, people like APJ Abdul Kalam and others were the giants. It reminds us that we are not isolated beings, but rather a part of an interconnected web of human knowledge and progress. The chairman, I am sure, will agree with me that the success of ISRO missions is mainly due to the principles of collective intelligence and collaboration. Now coming to the chief guest, Somanath was born in July 1963 as a child of Sri V. Sridhara Panikar and Srimati Thangamma at Thoravur in Alappuzha district. Somanath, an alumnus of Maharajas College, Ernakulam, took his BTech in Mechanical Engineering from TKM College of Engineering, Kollam, Masters in Aerospace Engineering from Indian Institute of Science, Bangalore, and PhD from IIT Madras. He has been bestowed with many honorary doctorates as well. I'm happy to note that some of his batchmates have joined us here. Dr. Somanath is the 10th chairman of ISRO since 14 January 22. He has a career spanning nearly 38 years and is an expert in the field of space technology and systems engineering of launch vehicles and has made significant contributions in many areas. Earlier, he was the director of VSSC during 2018-21 and director of LPSC during 2015-18. As Secretary, Department of Space, he piloted the National Space Policy. Chandrayaan-3 soft landing near the south pole of Moon on 23rd August 2023 was a great success under his leadership. The Aditya L1, Ocean Sat, GSAT-24 are some of the recent successes under his leadership. Small satellite launch vehicle and test vehicle were developed, and landing experiments of the reusable launch vehicle was accomplished. According to me, this is a very significant step of ISRO. He is a fellow of International Academy of Engineering, International Academy of Science, Aeronautical Society of India, Astronautical Society of India, and a member of International Academy of Astronautics. He is the president-elect of AESI and president of Society of Aerospace Quality and Reliability. He has published papers in the area of structural dynamics and control, materials modeling, dynamic analysis of separation mechanisms, etc. We hope that during his address, he will explain the two major upcoming projects, Gaganyaan and NISAR satellite. As you all know, Gaganyaan project envisages demonstration of human spaceflight capability by launching crew of 3 members to an orbit of 400 kilometers for a 3-day mission and bring them back safely to Earth by landing in Indian sea waters. Group Captain Prashant Balakrishnan Nair, a test pilot in the Indian Air Force, is one of the 4 designated astronauts trained by ISRO to fly aboard the Gaganyaan crewed flight. NASA ISRO Synthetic Aperture Radar, NISAR mission, is an observatory being jointly developed by NASA and ISRO to be launched in 2025. To conclude, കേരള സംസ്ഥാനത്തിൻ്റെ ഒരു പരമോന്നത പുരസ്കാരമായ കേരള പ്രഭാ പുരസ്കാരം ശ്രീ സോമനാഥിന് നൽകാൻ തീരുമാനിച്ച സന്തോഷകരമായ വാർത്ത നമ്മൾ കേരളപ്പിറവി ദിവസമായ നവംബർ 1 അറിഞ്ഞതാണ്. അദ്ദേഹത്തിന് അഭിനന്ദനത്തിൻ്റെ 1000 പൂച്ചെണ്ടുകൾ. അദ്ദേഹത്തിനും ISROവിനും ഇനിയും ധാരാളം വിജയങ്ങളും അംഗീകാരങ്ങളും ലഭിക്കട്ടെ എന്ന് ആശംസിച്ചുകൊണ്ടും പ്രാർത്ഥിച്ചുകൊണ്ടും നീണ്ട കയ്യടികളോടെ പ്രഭാഷണം നടത്താൻ ഡോക്ടർ സോമനാഥിനെ സ്നേഹപൂർവ്വം ക്ഷണിക്കുന്നു.
Dr. Somanath's visionary leadership and pioneering work in space exploration have been instrumental in advancing India's capabilities and reputation on the global stage. And it is indeed an honor that we have him here with us today. Ladies and gentlemen, boys and girls, please join me in welcoming our chief guest, Dr. S. Somanath, Chairman of the Indian Space Research Organization, as he steps forward to deliver his lecture on India's space missions. Sir, the floor is yours.
Okay. So, good afternoon, all of you. Can you move out, our cameraman? I want to see them. Sri C.A. Venugopal C. Govind, President of this function, Sri Ramankutti, Professor Ambad Vijaykumar, Mr. C.A. Shankaranarayanan, Srimati Meena Vishwanathan, and many other distinguished people who have been assembled here, the principals, former principals, students, and the entire Bhavans community. My greetings to you all on this occasion of this opportunity for me to speak about India's space missions. I'm really thankful to have said all those nice things about me. But before I talk about me, I think it's important to talk about ISRO. I think I am only a representative of ISRO, the community of space scientists in this country who have been working very tirelessly to raise the bar of excellence in the last so many years. And it is a teamwork of our family, along with many other stakeholders in this ISRO, the industries, the startups, the academia who have been part of this journey, made all this success happen in the last 60 years. And also inspiring leadership from many, many people, starting from Sarabhai, Dhawan, and many others. Not just the chairman, but also many other leaders. Our organization is like this, that we simply create leaders at very many places, many of them. Not the one who are, that you are able to see as chairman like me, but there are many other leaders who are able to do things, fantastic work across centers and laboratories and places. So I salute all of them before I speak about the space program. I think it's something which you should all learn, how to work in team to really to make a change. This is something which is lacking in our country. That's why I want to stress this point once, every time, again and again. Many people who know Dr. APJ Abdul Kalam really knows the trick, how to inspire ordinary people to do extraordinary things. I think this is what he is specialized in while he was in ISRO. I think we are all ordinary people, no? All come from surroundings like this. I am also a student of this Maharaj College just nearby. I came from a village adjacent to Kochi from Alappuzha district, Arur, where I used to take a transport bus every day to come to Maharaj College to have my pre-degree class at that time. Went back every day evening, walking from Maharaj College to bus stand, and then taking my transport bus to go to my home. Just an ordinary person. I got an opportunity to become an engineer, to serve this great organization and become chairman. How is it possible in this country? It is possible for each one of you to dream like that. Not to become a chairman, but to do much greater things. I think it is also possible for each one of you. Because our country is so rich in its knowledge and skill and culture, as already been told by Sri Govind, that we must be inspired by what you have been, and it is important for us to recreate it for the future. I think this is something that we must all be very proud of, and I am very proud of what we achieved in space in the last so many years, which I want to showcase a little bit of to you, and also to unveil the vision that we have set for ourselves next 25 years, what we really want to do in space. But it is not space alone that we want to work. We want to work in so many areas as a nation. I think for us, it's just not space technology that is important. It is more important is the nation. And why I say this is because by creating examples, people start believing in ourselves. What happened to us is that we lost our self-faith or trust in ourselves, in our own capabilities, in our own strength. I think this is something that needs to be brought back. And each one of you can play the role. Each one of you should play the role in recreating that lost strength. And with that, we can come back. For what? Again, you will ask, to come back to what? To create a vibrant life in this country. This nation, as an Indian nation, should be very powerful technologically, economically, and in your possibility of living a high standard of life. I think this is what we aspire. For that, we have created some examples. Many sectors have created examples. Space is only one of them. And it requires young people who, for the next 25 years, you are going to lead that role. You are going to be the leadership for the future. Sometimes you will become professors, sometimes you will become institution builders. You will become leaders in many sectors, political, technological, educational, any domain you talk about, some of you will become. For that, we need inspired people. That's why I am coming here to speak to you. Okay, so shall I begin? At the end, I want to give you some time for asking questions. So you'll be ready with the questions when I present. My presentation is nothing but pictures. There is no much of text to read from this. Okay? So if you give me an opportunity to move slides, good. Okay. If I talk about the stock of what we did, I talked about ISRO, but if you really look at the statistics, we have done 200 and odd missions, launching rockets, building satellites and putting in orbits. If you count them with this many numbers. But the most interesting thing for me is to look at the satellites we launched for other countries. 431 satellites of other nations, 34 different nations we have launched using our own rockets. Is it a small number? Definitely not a small number. Why I say this is important is, when we started launching our small sounding rockets from Tumba, at that time, Americans were already on the moon. And we are going to launch American satellites, European satellites. The next launch of PSLV is with a European satellite. European Space Agency satellite has just come yesterday morning to Sriharikota, and we are going to launch them. And we are into commercial launches of other countries' satellites. It's really a great thing to happen. People have faith in our own rockets that we can put them in space. It's a great thing for me. And there are many other things we did. I'm not going to explain. I think many of you can read about it. Internet is all available to you, know. Speaking to you on a young generation of people for all the story is not really wanted. But I want to stress you only these points that we were now trusted by many other space agencies. We are shoulder to shoulder with others. Other agencies like NASA or European Space Agency or many others, they look at it with great awe. How you are able to do this in this nation. When you come to this nation and look at around us, you see chaos, you find not so clean cities, you see, you call it mighty chaos, in between this you are able to do these fantastic things. No? That's why people are surprised. Can you run it? That's a video. No, there is no sound. It's okay, don't worry. The sound is what I am only going to give the sound. No, rocket sound is not there. But if you want to hear the sound of this rocket, you must all come to Sriharikota. You know where it is? It is near Chennai. From Chennai, it is 100 kilometers away. There is a beautiful island. And its island, we have the launch station. And you must all come one day and watch this. How we build rockets and see the rockets fly. Are you ready? And I am inviting you for seeing the launches. Because for every launch, we have a huge gallery. 5,000 to 10,000 people can sit there and watch the launch. You can go very near to the rocket during launch. But you can sit there and hear the rocket. The sound will come to you. It will hit your chest. You will feel the thumping feeling. You will see it rising majestically if it is a good daylight launch. If it is a night launch, it will still be beautiful. So come there and experience the launch and see the trail of the flume that goes. No, it's a very beautiful sight. And this sight will inspire you to aspire more. I think that's what I want you to see from this launch. And going closer and seeing the rocket, it's again another mesmerizing feeling. Though it looks such a tiny rocket, no, really it is huge. The rocket which is launched, it will one end to another, it will be bigger than this auditorium. The base itself will be bigger than this. It weighs 640 tons to put just 4 tons in orbit. So it's a mighty rocket, and I was fortunate enough to be part of this project and become the first project director of building it. And really, I'm very proud of showing this video many times. Now, if you look at our rockets, you have heard about PSLV, the GSLVs, and the LVM3, which just now you saw the liftoff. And many of them were developed after I joined. So they said I am 38 years into ISRO. So fortune to me is that I have been part of all of this. And I am going to be part of that last rocket, the NGLV, for some more time until I retire and go away. But right now I got an approval that we have completed the preliminary design, and then we started the design development program. But until then, all these rockets were developed, huge amount of infrastructure got developed. And I can tell you the knowledge of designing and developing a rocket is just not coming. Now you can't learn from a textbook and make a rocket. There is a rocket equation. Somebody has written a rocket equation long back. You know who wrote that rocket equation? Anyone knows? There is a great scientist, a Russian scientist, Konstantin Tsiolkovsky. Heard of him? No. Okay. But at least you should search this. So noted this name, Konstantin Tsiolkovsky. Go and search what is rocket equation. And he laid the foundations of this rocket. And this rocket are still flying on the same principle as Konstantin Tsiolkovsky did in 18th century. And being part of this rocket development is not textbook knowledge. There is huge amount of knowledge that comes out of experience, skill in many, many domains. So, you know, any aircraft India has still now made, the first aircraft we made, the LCA, have you heard about it? LCA, Light Combat Aircraft. Even for that aircraft, the engine comes from outside. The engines are still not made in India, even aircraft engines. But you look at these rockets, all its engines are made and designed, developed and manufactured and tested in India. Is it a small thing? And they are very powerful engines. Liquid engine, solid engine, cryogenic engine, non-cryogenic engine, control engine, satellite engines, all are designed and developed in this country. And we are able to make it. And over so many years, we were able to know the technology that does all of this. And look at the Gaganyaan program, human spaceflight program. This is going to be a huge challenge for us. We have developed the rocket. We have been sending satellites in space. But sending a human being to space is a difficult issue, no? Why it is difficult? Because he must reach there alive and thriving. And after reaching there, you should be able to bring him back safely. So not, this is the issue. Launching him is very easy. We will put it in a container and launch him to space. But there is no guarantee that he will come back. Okay, so not only that launching, but during launching, he must survive the launch. The accelerations are very high, the vibration is very huge, the thermal issues, and so many issues are associated with the launching human beings. The safety is very important. So bringing in safety in rocket is a huge challenge. And we are doing it, and we are going to develop G1, G2, G3. All of them are going to be uncrewed missions, where you will put a robot and then launch and understand what are the environments of launching. And finally, we will do a H1 mission, which will be a human-rated crewed mission. Our astronauts are ready. They are undergoing training. They are going to go to International Space Station next year. But launching our own missions, we are getting ready with the crew craft. What you see here, the crew module, it's a very complex engineering piece. And also the service module, both are getting integrated here. If you come to ISRO's facilities, I can show you that. I can guarantee you some of the selected students from here. If you are ready, I can show you how these are getting assembled and integrated. Some of you are interested. Now, another interesting area is aircrafts and aircraft-like rockets. That's called winged rockets. Can you tell anyone, a winged rocket which has been there some time back, has been working very well? American rocket. Space shuttle? Anybody knows? I think you would have seen space shuttle going there. And which Indian astronaut died in the space shuttle crash? Yeah, you know it. But then space shuttles are not flying today. America made the first space shuttle. Afterwards, Russia also made their space shuttle called Buran. It flew only once. After that, they discontinued. But then the world has still interest in building winged aircrafts, and we are also building similar ones, and we call it the reusable launch vehicle. And this is what the world is interested, because it's going to be unmanned. It is an autonomous rocket we are going to launch and then recover it on landing site. And that's what you will see now. See our craft coming and going to land in the defense runway in Chitradurga in Karnataka. You can see that how beautiful it is landing. And this is unmanned. And the entire computer system controls it. It is dropped from a helicopter at 4-kilometer altitude. It aligns itself, controls itself, and comes and lands beautifully. And now we are going to launch it to the orbit, and then from the orbit it will come back. But you would have seen aircrafts landing. The pilots are controlling and making it land. But autonomous landing is much more difficult, because it has to have sensors to understand this is a runway. And even if it is deviated, it will come back and land in the runway using optical sensors, radar sensors, lidars, which will measure heights. You have a pseudo lights which will locate GPS equivalent locations, and many sensors, and a lot of software and algorithm which will make it land beautifully. And when it lands from space, you need to handle thermal, high heat, drag, and it comes and lands at tremendously high speed than typical aircrafts. It will be almost twice the speed of an aircraft when it lands. So these are the challenges of making aircrafts like this land beautifully. So look at the pictures. In fact, last 3 launches, we were able to achieve it, very precise landing, perfect landing, even without centimeters misalignment. When it landed finally, it was exactly at the center of the runway. So beautiful it was. Now let me speak about some of the Chandrayaan programs. I think already we spoke about Chandrayaan 3, but the Chandrayaan 3 is a legacy. We started Chandrayaan 1 in 2007, and Chandrayaan 2 in 2019, and Chandrayaan 3 2023. But the Chandrayaan 1 is very important, because through this mission we've discovered what? Chandrayaan 1 discovered what? Water on the moon. Even before that, many missions were there. Americans went to moon, Russians went to moon, and many other nations went to moon. Did anyone discover water on the moon? No, it is our Chandrayaan 1 which put the moon impact probe as well as observed using our own instruments and also American instruments. They discovered the water on the moon. Today, everybody knows there is water on the moon, and there is a possibility of even finding icy water on the moon. So that's why it's important. And Chandrayaan 2 is very important because, okay, before that, let me see you Chandrayaan 3 landing. This view, many of you would have actually seen and witnessed Prime Minister looking at the landing and all of us clapping hands when it landed perfectly. So it was such a proud moment for all of us to watch this and then get inspired by Prime Minister. Even after this landing, on this day, he was at South Africa. And straight from there, he came to Bangalore and congratulated each one of us on the next day. So it was such a proud moment for all of us. But no, I am telling you this about the Chandrayaan 1. Chandrayaan 1 was launched using a PSLV. At that time, the bigger rocket was not available. So we designed the Chandrayaan 1 as a small satellite, put it in the orbit of the moon, and the mapping shows the presence of water on the moon. Our imaging showed that everywhere there is presence of water on the moon. It's such a fantastic finding. And even the mission that we achieved from traveling to Earth to moon was again very unique, slowly raising its orbit and finally being captured by moon and then entering into the moon orbit. And we could do it with even a rocket like PSLV, which has a hardly 1.5 ton payload capability. No one in the world would have ever done such a mission. That's why we were able to do it at extremely low cost. The innovative approach to make the satellite move from Earth orbit up to the moon. I think this has been very unique. You understand, these are all mathematical techniques, how to move from an object from the moon, Earth to moon. The computation is very complex. I think we were able to do it very precisely and achieve it. And you know, the Chandrayaan 2, I was very much there, part of this mission. The rocket which we made, and it was getting ready for the first operational mission. And when this was getting ready, we offered it for the Chandrayaan 2. And Chandrayaan 2 was similar to Chandrayaan 3, but it didn't achieve the soft landing. But the beautiful part of it is the orbiter, which is still functioning on the moon. It produces the best images of the moon ever since the people started traveling to moon. We have high resolution images. Every 25 centimeter space on the moon can be very clearly seen in our images. Today, our images, Indian Chandrayaan 2 images, are much sought after by the world. Even the Americans use it, Russians use it, the Japanese use it for their moon mission. And we are the one who supplies all the images to them, and they plan their trajectory based on our images. Is it not a proud thing for us? Of course, Chandrayaan 3 is well known, and I like the Chandrayaan 3 not because it made the soft landing. The rover came out and traveled almost 100 meters on the moon, and it did a lot of experiments. We had experiments on the lander, the Vikram lander and the Pragyan rover. The Pragyan rover had experiments to do studies on mineralogy. It has a laser light. It will ablate the materials and take a spectroscopy of the material. And it can study what all elements it is consisting of. It also has an alpha particle emitter supplied by our atomic energy, and it is used to create alpha emission and then again create the similar spectroscopy of that to find out material. So in such a tiny volume of 27 kilogram, we were able to put these instruments, its autonomous rover, power generation, computer control, communication, everything. And it traveled beautifully without falling into any of the gorges on the surface of the moon. It was almost about to fall into one pit which was there. Luckily, we were able to find out using the cameras. And it also produced that beautiful image of Chandrayaan 3 sitting on the surface of the moon. And there are many more images, but this is the one which has become very iconic. Everybody looks at this image. It was a black and white image because we put only a black and white camera because it was such a small, tiny thing, and we couldn't put a color camera because of the data limitation. From moon to earth, we cannot bring very heavy data. So we have to put very minimal capability. So, and this is very interesting. And all the 5 experiments on Chandrayaan 3 work beautifully. I think this has been the most successful mission, but it lasted only 14 days. In 14 days, we had to close down. The Chandrayaan 3 was made to sleep and didn't wake up after the 14 days because day and night as, on moon, only 14 days are days and another 14 days are nights. So after the night, it went into a deep freeze and it didn't wake up. We are hoping that it will wake up, but it didn't happen. But then in the future, when you do future missions, we will make sure that there are methods by which it can wake up. We need power generation in the absence of sun, possibly using atomic energy principles. We should be able to create power generation capability. Can anyone tell this what image of this is? It is a Mars. Okay, the most beautiful image, the three-dimensional image of the Mars was created by our Mars orbital mission, MOM. And this was again very unique mission that India did. The very first time any country has ever sent a mission to Mars and became successful. That was India. And it was not because that we were just lucky. Because we studied all other failures and made corrective actions on our mission that we were able to achieve the success. So, but look at this, it's such a beautiful image. I'm not showing you much of the outcome. Another interesting mission is Aditya L1. I think just mentioned about it. Aditya L1 was very unique because we were trying to study sun using many instruments. You will ask me what you are going to do about sun. You can see sun every day. What exactly you are going to study? You look at the sun from Earth and then study sun. But then once you go up above the space, you can look at sun in various ways. Not by the visible light. You can look at the particle emissions. Now from sun, whenever a coronal activity takes place, a lot of particles come. And what are the particles? It will contain electrons, protons, ions of various elements. They travel at tremendously high speeds towards Earth because of the magnetic activity. And these particles also create emissions in X-ray, hard X-ray, soft X-ray. It also gives out ultraviolet radiations. It gives magnetic activity around the surface. So we put 7 instruments in Aditya L1, looking at the coronal emissions, looking at the particle emissions, looking at the magnetic activity, looking at the X-ray and ultraviolet activity, and we can take all these images together and understand the connection between coronal mass ejection and we call it space weather, what happens on Earth back home because of all this effect. You know, corona borealis and corona australis, those emissions at the poles that you see due to the impact of those particles coming and interfering with the atmospheric ions on the surface of Earth. We can see those colors, beautiful colors changing, green, red, yellow, colors are changing. Even if you go to Ladakh in India, you can actually see images at the poles being created by the coronal activity. Recent years, it has been very intense. Recently, Aditya L1 discovered many of the coronal activity and a lot of data has come. Today, we have 50 plus satellites in orbit. India has built and launched and almost 100 satellites, but what is working today are 50 plus satellites in the last 60 years. And it contains communication satellites. All your communication needs like the television broadcasting, the DTH services, the VSAT connectivity, internet services, backhaul, your mobile services has a backend support using satellites. All these are done by communication satellites. We have Earth observation satellites, we have navigation satellites and science satellites. And this just 50 only. India needs 500. We have only 50 satellites. We need to build more. And this is very important for us. So let me speak about some of the important satellites that are coming up. The ISRO satellite, NASA, ISRO synthetic aperture radar. But sorry for the poor quality of the image. But the actual image it will send from space will be really fantastic. You know, this is one of the biggest satellite that you are ever building. It is currently at Bangalore. NASA people are working with us from Jet Propulsion Laboratory. And they are building one part of the payload. Another part of the payload is going to be built by Indian scientists. It's a radar imaging satellite, not a, you know, radar can see you people. Radar is not like a camera. Radar is a signal which will be sent. You collect the signal back and you can actually form an image using mathematics, complex mathematics. So you can understand many things. You can actually observe the surface. You can look at the tectonic movements. You can see water. You can see ice. You can find pollution. You can see green cover. And you know, tectonics is very interesting. All the continents move. You understand continents and all of them move slowly. This satellite can measure movement up to 2 centimeters in a year. Up to that accuracy it can measure. And in the summer and rainy season, water goes under the earth and lift our land mass in meters. Sometimes half a kilometer it goes up and down. With respect to Earth's surface contour, the change is almost half a kilometer up and down. You can measure it and understand how is our underground water is getting collected and water is getting used. A lot of such information can be gathered using the satellite. And this satellite is going to be launched coming February. Similarly, another satellite we are building is with the CNES. You can check it. CNES is a French National Space Agency. It's a France. We are working with them to make a satellite called Trishna. It's a thermal imager satellite. So you look at Earth in thermal band. When I say thermal band, you won't understand. You know, if there is a hot object sitting here, you put your hand, you will feel heat. You physics students, you can understand heat comes out as what image, what radiation. Anybody, somebody tell me, answer me, what's the radiation through which the heat is transmitted? Infrared, ultraviolet, which is the one? Infrared. So infrared radiation you cannot see. You know there are infrared cameras, night vision cameras, infrared LEDs. So similarly, if you look at Earth in infrared, you can actually map Earth in thermal way. And once you map Earth in thermal way, you can understand the heat stress, the impact of rain, impact of global heating, the emissions of carbon dioxide, methane, and global climate change, and many other aspects can be studied using the satellite. So we are building the satellites now. And there is another interesting satellite we are building is called G20 satellite. This is a satellite for G20 nations. Recently, Prime Minister has announced that the G20 nations are going to build a satellite, and India is going to build it for all of you. An offer that we are given, we are going to build a satellite for all of you. For what? For environment and climate studies, because environment and climate studies and sustainability is such a big issue today. We have to look at what are the carbon emissions happening there, how much of global warming is happening, and how much of precipitation rain is happening, what are the pollutants globally, and how they are moving around, and how we can mitigate all of this. So we are putting instruments on such a satellite, and we will measure globally and provide this information to entire nations to take actions to correct it, wherever there is a need to correct. So this is one interesting satellite we are building. Another interesting satellite we are just going to build and launch is called SpadeX. This satellite is just ready at our satellite center. The launch is likely to take place by 20th of December. All of you watch for this launch. This is an interesting satellite. There are two satellites, and these two satellites will be launched separately, and they will move around 20 kilometers apart, again come back together, and we will dock each other. They will connect each other and demonstrate how to make assembly in space autonomously using computers, no human beings, okay? And we are going to program it. You are planning it from ground and commanding it and make them connect. Just imagine two cars moving on the road at 100 kilometers. Can they ever come closer and touch, connect? Just 100 kilometers per hour. You know what is the speed of the satellites in orbit? It is 7.8 meters per second. How many kilometers per hour? Anybody has calculator now? So it is tremendously high speeds. So at these high speeds, if two objects have to come in centimeters close and connect to each other, it's a very huge task. And no one is there to control. Everything has to do itself, using its own sensors, computers, and grabbers it has to do. So this is beautiful activity, because this is important for us future. When you send human beings, if you have to go and dock in International Space Station, we must have this knowledge. We must have this technology. So for that, we are building this. And similarly, another interesting satellite is a TDS-01. This satellite is going to use electric propulsion. Electric propulsion is, propulsion is the thrust that you are giving to give the rockets, no? Satellite also got engines where you burn some fuels and push. Electric propulsion is where you are going to use solar power and then generate the solar power to give the push to the satellite. So you don't need that much of fuel. We need a really less amount of fuel, and the electric push can give you very high push. So it is 10 times efficient than chemical thrusters. So we are going to test it in our coming mission. Another interesting satellite is the quantum key distribution satellite. It's called it SAQTI. You find out its abbreviation. I'm not going to tell you. Okay? So if you search, sometimes you will get it, sometimes you may not get it. But don't worry, after some time you will know what it is. But this is a technology demonstration to do quantum. Have you heard of quantum? Everybody is speaking about quantum, but have you understood what it is? You don't know. Okay? But the quantum key distribution is a technology in which you want to do securing. You know passwords. Every file you can use a password and lock it. After that you lock it, you cannot open without the password. So quantum key distribution is like a password. If there is a communication link, you can use a password to secure the communication. At the other end, you need to supply the password, then only you can open it. So others cannot break in. Quantum keys are something that you cannot break at all using regular computers. Whatever you do, such a key cannot be broken. So this is a security that you are going to build using quantum technology. Yet another satellite we are building is called software-defined radio satellite. Entire satellite is a software-defined satellite. You can program every satellite's frequency, bandwidth, its footprint, etc. Possibly students may not understand at this moment. Have you heard of NAVIC? How many of you have heard of NAVIC? Raise your hand. Only one. I am happy to see one at least. It is equivalent of GPS. No, where is GPS used? One place where GPS is used, can you tell? In your mobile phones? Where is it? What for you are using GPS? Are you using GPS or you are using Google Maps? You use Google Maps and use navigation, but GPS is inside it, no? It uses GPS, you know, but you are not directly using it. But GPS also can be seen, this is a GPS is a American service, no? You are using it part of the Google. But there is an Indian equivalent of that is called Navic, and we provide it over Indian subcontinent. But signal has not come into mobile phones. So today we give it to defense. So we have 9 satellites and it gives in different bands, and we are going to increase it in the future, and after some time it will be there in your mobile phones also. Please watch for it. Those who want to again find out, I am giving you this keyword. Those students who are interested can search it and find out. Navic, if you try, you will get a lot of information. Please study it and how it is important for the country. But we do a lot of things using Navic. For example, okay, before going into that, I will speak about some of the application side that we are working. The first one is called Tele-Education Network. We run something called Tele-Education. We have a remote schools. If we can, some teachers here sitting can actually give a bidirectional communication contact classes. Another area is called remote medical services. We run a lot of nodes across the country to support medical care. And this is specifically connected with some of the specialty hospitals and remote areas like hilly areas, defense areas where there are people access is limited. So these are some of the communication-based services. Yet another satellite service is called Satellite Search and Rescue. So if somebody gets stranded in a hill or in ship or in helicopters, or they go to a forest and they are lost, if they have a beacon, if you press once, our entire satellite network will come into action and somebody will go and rescue him, provided he has that system called a beacon. And we have so much of area, the colored areas are covered under Indian satellites, and we provide satellite services to do this as a global service. It's a free service, and our satellites has payloads to collect this beacon data, and it will be communicated to the nearby service. Either it could be a ship or an aircraft or a people, they will go and rescue. In the last few years itself, we have saved almost 2,000 plus lives using this technology. And it is one of the best services that India gives to the global world, and it's been recognized recently. We got an award also as a part of our service that we are doing. Of course, all of you know about this part of it. Whenever there is a cyclone comes, you can see this in our newspapers, it will see in your TV. You know where from this image comes? This image comes from a satellite called INSAT. We have 3 INSATs, INSAT 3, INSAT 3, INSAT 3D, 3DS, 3DR, and they produce these images of cyclones, and even before it is actually formed, we can predict how it is going to be formed, where exactly it's going to be formed, and there are mathematical models which will predict how it will move and what point it will go and hit. And these predictions are done week ahead, and governments can warn people to relocate or do protective actions to prevent any mishaps happening. You know what is the last of the cyclone that came in Orissa? Not Fani. Fani was old. Anyone can tell the name? Okay, the last cyclone. No one knows. Okay, I will not give you answers. I am not here to give you any answers. You have to search and find out. Everyone has to go internet and search and find out. But these names are very interesting. These names are given by cyclone. Who gives the names for the cyclones? This question you have any time asked? There is a cyclone called Amphan. Who gave this name? So there is a method of giving names, and 7 countries in and around this Indian Ocean has a right to give the name. India gives the name once, then the adjacent country will be Bangladesh, then Myanmar, Sri Lanka. Each one has a right to. So the names are already written down. All future cyclones' names are already written down. You are only, okay, now the cyclone is there, this name you give. So it's already written for next 2-3 years, names are already allocated for future cyclones. Okay, so that's the interesting part of the cyclone naming. Those who are interested, you can again search and find out. But then our satellites find out the cyclone very much early. So today, the damage to the property, the damage to people, the death, etc., we are able to control substantially less. And that's a great part of it. Equally important part is looking at the natural calamities. Can anyone identify these 2 images? Anyone? Wayanad. Okay, where we had the landslide, the images were collected, we supplied to all our rescue people, but of course, there is an issue with the landslide is that when landslide happens, you cannot give real-time warning, because exactly at that time, there will not be a satellite up there. So this is one of the weakness that we have. We have to overcome this and create more satellites to help this type of issues. But these are the images which was taken afterwards, maybe half an hour or 1 hour later. By the time, much of the damage is already done. But you can see that similar possibilities have been mapped all across the country. We have technology to map the hilly areas, the danger zone areas. We call it the landslide inventory. So this is a map showing the landslide inventory of the country. Every state is provided this information, which are the locations where you should be very careful. And you should continuously monitor, especially when you have heavy rains and such situations, these areas must be under surveillance. So this is one of the important capability of satellite. We can actually estimate how much damage is done. The recovery and reconstruction activities can be handled very effectively with the satellite data. Oh, I also want you to search this word called Bhuvan. What is the meaning of Bhuvan? Bhuvanam. But then there is a site called bhuvan.nrsc.gov.in. If you search this, you will get a beautiful website called Bhuvan. And this Bhuvan is a website that we have created and put every data corresponding to this country, India, into that website. It could be all the satellite images that has been collected in so many years is already archived and available. It's not only the satellite data that we have. We have huge amount of data about infrastructure that we have created, road network we have created, dams, even the village level information, like all the telephone exchanges, all the post offices of this country, every heritage sites of this nation, every island of this country. You know how many islands India has got? Anyone can tell? How many islands? Can you anyone tell? Is it 10? If you believe there are only 10 islands, raise your hand. 100? 1,000? Very good. I think we have thousands of islands. You have a Lakshadweep, that doesn't mean that there are lack of islands there. We have thousands of islands. So all the islands are mapped and available as information in this. Not only this, that you have huge amount of information to agriculture, water resources, our networks of infrastructure that we are creating every day. Even the Manrega, the every day they build a little bit of roads or some canals or everything. Even that is geotagged and information is available in this website. So it is useful for people to do planning of their village or even to plan the network of activities, the infrastructure building, new networks of like piping or power networks, everything is used by this information. So please search and find out, but it's not available to everyone free. Those who access it free will have a limited information, but if you register and become a member of user community, you will get huge amount of information about India. This is equivalent of Google Earth. You know, anyone of you has used Google Earth? And similar to Google Earth, it is specific to Indian web portal that is created out of our Indian satellite data. Similarly, we supply huge amount of information to the climate and weather prediction community. You know, in India, the climate and weather prediction is done by one organization called IMD. They are the authorized to do the modeling, prediction, and telling you, okay, today there will be rain here, today there will be drought here, this is the temperature profile, today wind will be in this much. But for all of that, there is a huge amount of data required. Who gives this data? Our satellites gives this data. And also there are land-based data also. So land-based data plus satellite data together, they make a computer model, and this computer model is run in Delhi in their supercomputer center. And the output of that is given as the climate and weather model for this nation. Of course, you would have noted that earlier in some maybe 20 years, when the weather people predicts, Maya ondagano, ondagadirikkano, sadhyadayundennu parayunna pole. Today it is not like that. When you predict rain is going to happen, it is really going to happen. So the possibility of the accuracy of the prediction has improved. But of course, for a country like India, this accuracy will be an issue because we are a tropical nation, and tropical prediction capabilities are actually not up to the mark as in the other part of the non-tropical areas. So there is a challenge of modeling and predicting here, but weather prediction has improved dramatically because computational capabilities, modeling capability has tremendously. This is one interesting area. Those who are interested in physics, mathematics, computation, this area is hugely very good domain. You can study it, how to computationally model the weather, modeling of Earth, modeling of climate, modeling of sea, modeling of the entire ocean system. It's a really mathematically very, very interesting topic. Let me tell you a little bit about the future. I think all of you would have noted that we have created a future roadmap for India, the Space Vision 2047. We have said that we will have an Indian landing on the moon by 2040. 2040 is not far away. I think all of you will see to it that we will watch this landing one day. But before that, we need to have many, many things. We want to create a space station called Bharatiya Antariksha Station by 2035. We want to have many Chandrayaan missions. We want to create a new rocket, much more massive and mighty than the current rocket, so as to take the human beings to space. So this vision has been recently announced by Prime Minister. He's not only announced it, he also granted us some money. The approval for the projects have already been done. The budget today has been granted is almost 30,000 crores has been granted to us, and we were asked to do this work in next 5 years to build the heavier rocket, the Bharatiya Antariksha Station first part, and Chandrayaan future part of it. So it will look like this. We have a 5-module Bharatiya Antariksha Station, and the first launch of this crew module will take place in 26 with the human beings, and the first module of the Bharatiya Antariksha Station, we want to launch it by 2028. The work of is already started in ISRO. Chandrayaan again, what I said is Chandrayaan 4, 5, 6, 7, 8 will all happen maybe much later. But today we have an approval for Chandrayaan 4. And the Chandrayaan 4 will take the Chandrayaan to the surface of the moon. It will land softly. It will collect samples from there, put it in another craft, go to the orbit of the moon, dock it there, and come back to Earth and bring it back, the sample back to us. So we want to learn the trick of how to go to moon and come back. The entire algorithm, the entire software, entire control, how to do the whole of this, we need to learn ourselves before we send the human being. So we have to do it robotically first. So we are developing this Chandrayaan 4, and we want to launch it by 2028. And also launch the next mission called Chandrayaan 5, where we will be sending a bigger rover, which will be almost 10 times bigger than the Pragyan. And we will take it in a lander and launch it along with a collaborative arrangement with Japan. So we are joining with Japan, the JAXA space agency, and trying to do such a mission called Chandrayaan 5. This also waiting for approval of a government. Only the first part is already approved. You can compare the size of Chandrayaan 3 there. It will be much bigger. But the most interesting story I want to tell you young people is that the space is not just this type of big vision, but also the participation from industries and startups have increased last few years. In the last years itself, we have 250 plus startup companies in space sector. Young people like those who are just out of college have started companies in space, either in data products, in developing new technologies, and we are helping all of them to come up in this level through financial support. We give technological support. We allow them to come to ISRO and work with us. And young people can actually now come to ISRO and work on your idea. And we will help you to how to scale up. And there is enough of money available in the ecosystem to help you if you have a beautiful idea. And I can tell you from those who worked with me in ISRO, some of the young engineers are resigned and started companies, and some of them own. The companies are as big 500 crore worth companies. In the last few years, about 4 or 5 years, they have scaled up to that level. So it's a great opportunity today to work in startups companies. And our interest today is to scale up and allow companies to grow and scale up this economy. And this is very, very important. Now, all of you cannot come and join ISRO, or all of you cannot aspire to become astronaut. But at least you can aspire to become a owner of a space company. Is it not? That is much more interesting. Then you can do whatever you want to do. Okay. But then another interesting thing that we do in ISRO is to reduce the import content. When we started the space program, huge amount of items were imported. But I can tell you that the last so many years, we were able to reduce the import content to almost 8% of the value of the rocket. Today, the rockets are made in India using Indian material, Indian skill in Indian companies. It's a great achievement. And many of those companies created the capability, but we still import about 8-10% of the material, and they are nothing but electronic parts and products, which are anyway not made in India. And this is also our interest to see that in the next few years, we create that capability to build it in India. But this is a great journey of bringing down the import content of our material substantially. And if you really want Atmanirbhar Bharat, this is very, very important. And another important thing is the technology available in ISRO is actually available to each one of you. If you really want to convert some of these ideas that we created into industrial products and businesses. We have been working in so many areas, and technology transfer has been happening to industries. Almost 400 and odd technologies we have transferred, and we will be transferring more of them. It will include software, hardware. I've only shown some examples, like the lithium-ion cells that we use in mobile phones, similar technology. All the spacecrafts and rockets use lithium cells of ISRO. We are building all the batteries within our labs, and we are using in our satellites. Can you believe it? We don't buy a single battery from outside. We do it in-house. And we have recently transferred the technology to a company called BHEL, and they are building now and giving it to us now. We started buying it last year onwards. Otherwise, we were doing it ourselves. So over the years, many technologies we have transferred. Even a satellite we have transferred. A full technology of a satellite is also transferred to private industry, and they are building it now. And even softwares we have started transferring. So it's a very interesting time for us in ISRO, working with private companies, young people who are interested to work in startups, and companies and also academic institutions in collaborative mode. They're all happening now. Come on. So I would like to end my talk with this and then allow further questions to ask. This launch should have happened. Yes, it is happening now. So we have a little bit of delay for human space flight, but then still it will happen one day. So this is a rocket that will take you the launch of the humans into the space. The rockets, each stages are separating, and finally the crew module with the service module is in the orbit. Our astronauts are inside comfortably. And after the few orbits, they are deboosting to come back to India and touching down safely in the Indian Ocean. And our ships are going and collecting it here. It is not going to be a dream. It is going to be a reality. Every day we work very hard to make that into a reality. Whatever you saw animation, each of those parts are actually getting ready. And we did some of the tests recently on showing, possibly you would have seen that video of the crew module coming back and landing in the sea without, of course, human beings. And we are working with our Navy and other Air Force teams to arrange the ships and crew systems all around the world to secure and safely collect them and bring back. All these are happening. And I am sure in next 1 to 2 years of time, you will be actually seeing our Indian flying to space, possibly going to space station, and ultimately in the human landing on the moon. All these are in our wish list, but all depends on how much you do progress in our day-to-day work. There are huge amount of work of design development happening in the background. So let me stop at this moment and thank you so much for this patient listening. Now I leave it to you to ask questions on topics which are relevant, or what are presented, or not even connected. Okay, whichever you like. Yeah, yes.
Thank you, sir, for sharing your profound thoughts. We now move on to the next segment of the program. The floor is now open for the question and answer session. It's a wonderful opportunity for our student community to engage with our speaker here. We have exactly 10 minutes for this interactive session, and we invite students in particular to raise your queries. I request all the dignitaries to occupy the seats on the dais. Can we have the first question, please?
Allowed only from students. You can't start. I won't answer your question, sorry. I will come to you later. I want students to ask.
Namaste, sir. How can students like us get involved in space science and technology? Are there any courses available, or what are the other ways we can get involved in it?
You are studying which class now?
11th grade.
Okay. So if you are interested in space science and technology, you need to choose your career path. Okay. It depends on what domain that you want to go. The spaces and technology is such a wide area. No, it's not a, there is nothing called space science. All sciences are there in space. For example, if you want to become an astronomer, astronomy is one domain that you can select. You can look at climate and weather. It's again space connected. So basically what you need is a good background in physics and mathematics. So you have to choose that you are going to study a science stream with a focus on physics and mathematics. And in your post-graduation, you can go to astronomy. Astronomy is not available as an undergraduate course. It is available only in postgraduate or higher learning. So, and similarly, atmospheric studies are available there only. Suppose you want to look at biology. Even astrobiology is a domain which is very, very interesting domain. You can become a biologist. You can also become an astrobiologist after graduating and post-graduating in biological domain. So looking at how life actually forms in stars and materials, etc. So there is a stream which is working there. Or if you want to become a space scientist like me working in ISRO, you need to become an engineer. Then you have to choose that you want to become you have to choose an engineering stream to design, develop space instruments, systems, satellites, launch vehicles, propulsion, materials. So there you can choose a branch of engineering which will be useful. But there is nothing called space engineering. The right approach is conventional engineering like mechanical engineering, chemical engineering, civil engineering, electronics engineering, computer science will do. But then after that, if you are selected to ISRO, you have to do a post-graduation or higher studies to leading to the specialization. So basically what you need is a passion for that higher goal, but today to work on core areas of knowledge, physics, science, engineering, look at the core area and develop a high level knowledge and skill. Rest you can take a decision what branch of specialization that you can go later. But there is, of course, there is a space-based space science courses are there. For example, Indian Institute of Space Science and Technology. After +2, if you write a IIT entrance examination, you can get into IIST, Indian Institute of Space Science and Technology at Thiruvananthapuram. If you get admission there, you are straight into space. Okay, you will be, without any difficulty, you can get into space research area. There are other institutions called IISER. There are so much of specialization there which can lead to space science and related research. So some of the institutions like Indian Institute of Astrophysics, there are various labs across the country which will work on astronomy and observatory science related area. There is another institution called Raman Research Institute at Bangalore which works on material research, fundamental physics related areas. So Mathematics, Institute of Mathematics Research at Chennai works on basics mathematics, high-end mathematics related to space mathematics and origins and things like that. Theory of relativity and those type of high-end physics problems. So you have to choose what domain you want to do, to take your career accordingly. Okay.
I think we have a person here.
Namaste, sir. Sir, you had mentioned earlier that India will be building a space station in the future. Sir, what precautions should we be taking in case of a potential meteorite impact?
Yeah, you touched a very important point. Meteorite impact is a very serious issue. It's not meteorite alone that will impact. Meteorites are very rare. But real issue is the debris, space debris. So space debris meteorites are not man-made. It comes from other objects. But man-made objects are there plenty in orbit. Today we have almost 5 lakh parts of satellites and rocket parts are there orbiting Earth. 5 lakh. And they are all bigger ones, 1 centimeter and above bigger size. 20,000 satellites, almost 1 lakh pieces of 10 centimeter and bigger. They are all potential hazards. So there is no way to protect against a big piece. There is no way. If it hits, the whole thing will collapse. So only thing is you watch for it. If it is coming and going to hit, you move a little bit so that you don't hit. For that, you need to observe and understand whether it is going to come and hit you. For that, you have ground-based radars and optical observatories to watch continuously. And then there is a mathematical calculation done. And this is observed much early, and we will propagate. We call propagation. And then see, over a period of time, it will come and hit you. So this prediction is done. Based on that, you take advanced action. So it's again, accuracy of prediction, the ability of the model, etc. matters. Second is, something will come and hit you, whatever you do. they are all small items. But if small items hit, you have a technique called mitigation measures are there. So you get a protective shield. Every space station has a protective shield. And they are very, very critically designed. If it hits, it will develop a gas, because if it hit a metal, metal will get evaporated. And it will move at very high speed and impact on the shell. So not to puncture it, we keep some materials there which are attenuating materials in different layers. And they are designed in such a manner, it doesn't cause, by the time it reaches the critical surface, its velocity is very low. So this is called Whipfield shield. So we designed the Whipfield shield and protect the entire capsule is covered using Whipfield shields, like space stations. Okay?
Yes, sir.
Only students. Allah. Okay, come on.
Namaste, sir. Sir, I'm Pradosh Gopal Krishnan from BVM Erur. Could you provide an example of a high-stake decision that you made on an uncertain mission with an uncertain outcome, and what key factors influenced your decision-making at that moment? Thank you, sir.
Of course, it was not my decision, not personal decisions. We don't take personal, individual decisions at all in the organization. We make collective decisions. I'll give you one example. When Chandrayaan 2 was getting ready for launch, that rocket is ready at the launch pad. Chandrayaan 2 is fully integrated. The VIP to watch the launch was nothing less than the President of India, Ramnath Kovind. So he started from his guest house. He moved to the control center. So he just 1.5 hours before liftoff, 1 hour around before liftoff, he come and sit. But meantime, we observed some anomaly in the rocket. We found there is a pressure drop happening. And this observation was brought to my attention. So I immediately asked to bring the graph of that observation. So we want to understand. So immediately I asked my engineering team to bring the circuit of the whole pneumatic circuit. We call it pneumatic circuits. So it was brought. We identified where this could be a possible leak. And we asked we have to have an immediate plan what to do. So we immediately said to the team to boost up the pressure, see whether the pressure drop is still happening. We immediately boosted up the pressure and seen it is. All these are remote. We are not near the rocket. We are 10 kilometers away standing and doing everything remotely. The rocket is fully fueled, fully ready for launch. So we are doing remotely this observation. We have cameras looking at it, etc. Leak cannot be seen. But then we understood immediately that it is a case whether we have to hold the launch. Then some people started telling, okay, there is still enough gas, even if this leaks at this rate, by the time it is used, this gas will be still sufficient, so we can give clearance. Somebody will say, don't give clearance. So we need to take a decision at that moment. President is sitting, if the launch is postponed, he will have to go back. He has traveled all the way from Delhi and come here to watch the launch. Chandrayaan 2 is a very precious community. Whether you should allow this launch or take a chance to launch. And I said it must be scrapped. We must stop the launch. We must go back and look at what is the problem, correct it, and then only you should launch. So we immediately told everybody, we took a collective decision to abort the launch and went and told President, sorry sir, we have to come back again. Of course, he graciously accepted and left for the launch, but later he told me that day I couldn't come and see the launch. I will come and see a launch after maybe he came back after he relinquished his office. He came to Trivandrum and watched one launch of sounding rocket from Tumba. So we arranged that for him to see. But it was such a small rocket, but it is more emotional than the big rocket. So I want to tell you that decision making of this nature also happens. Maybe not so pleasant decisions where you will have to take a cautious decision of not doing something at the right time. Because failures are very much possible in this exercise. Rocket launching and satellite building is such a thing that even a silly oversight can cause a catastrophic launch, catastrophic miss. Is it good enough?
So I think the time is up. It's 10 minutes, but if you would like to take a few more. Yeah.
Namaste, sir. My name is Vinayak Prabhu of Bhavan Adarsh Vidyalaya. My question for you is, ISRO has started the country's first analog space mission at Leh in Ladakh. where the space agency will simulate life in an interplanetary habitat. So, what are the challenges or the risk factors involved in this mission?
No, there is not much of risk because it is in the ground. You can always abort and come out. Analog simulations are only to get the exposure of isolation, confined space, lighting issues, your cycles time. You have a biological cycle, and the biological cycle get disturbed, the physiological effects start happening, the low temperature there, etc. Okay, food, many other things. So you want astronauts or the so-called volunteers to experience this and find out what are the effects of it through a proper measurement. That's the purpose of analog space simulation facility. And there is no much of risk if you take appropriate care. Of course, there are risk of fire, risk of getting locked, lack of oxygen being Ladakh. You need to be careful because there is a depleted oxygen level there because of the height. Such things have to be taken care. Otherwise, there are no much risks.
Thank you, sir.
Namaste, sir. What initiatives does ISRO have to empower and train the local youth in remote areas, especially in the field of space research and applications?
My dear friend, I think ISRO cannot cover entire India. No, we do certain tasks which are specific to developing space capability. But to bring remote area youth to space technology, it is the responsibility of various other entities in this country. For example, educational, Ministry of Education, Ministry of Tribal and Rural Activities. There are various stakeholders in the country. What we do is we help them. For example, we provide them with the connectivity, we provide them with information, we connect with educational institutions to provide the data, we provide you the educational material, online material. We are a very limited resource people, so we can't go everywhere, but still we go everywhere. Whenever there are possibilities, we go to rural and village schools to conduct classes. I myself have been going in my past to go to give classes to schools, especially during the periods of Space Week, etc. But its reach is very limited. No, India is such a vast country. If you want to really look at the villages, you have lakhs and lakhs of villages in this country, which is not even connected. So this is a huge problem. I must agree that we are looking at volunteers. We are connected to space tutors. Another idea that we had is we have licensed space tutors, voluntary organizations who are willing to go out and give such connections. We provide them with the materials and data and provide license for that they can go and connect like that. Okay. Yes, sir. Now you can.
Namaste, sir. Your journey from Malapura to the chairman of ISRO, how do you feel? And we are proud of you. And do you believe in the existence of supernatural spirituality? We call it aliens.
No, I don't know whether there is a connect between Alapura and aliens. Aliens are definitely not from Alapura. Okay, jokes apart, you want to know whether aliens are there or not there?
It may, according to your wish.
According to my wish, but it's their wish. If aliens want to be there, they will be there. But I can tell you, guaranteed one thing, aliens are there. I can vouch for it. Do you believe?
That.
Yes or no?
Yes.
So you can sit down. So why I say is not just jokingly. So why I say aliens are there is because, see, the universe, you should have an idea about the universe, no? You, after living here on earth, you feel that this is the great thing and we are somebody very big. It's not true. We are such a silly thing on the surface of earth. The earth itself is an obscure planet in a system called solar system. The sun itself is such a silly star among the 450 billion stars of this Milky Way galaxy. And this Milky Way galaxy itself is one of the few billions, maybe, I don't know how many billion galaxies. They say it's around 100 billion galaxies. Out of that, this is one of the smallest galaxy of this universe. And this universe itself is one of the universes that existed exist or otherwise exist out of the billions and countless number of universes. And you say Earth is such a precious place? I think it is nonsense. If life is here on Earth, it will be there at so many places. So many places. I have no doubt about it. And if that is there, then people or creatures or living organisms brilliant than us will be existing. Sometimes not so brilliant, but it will sometimes very brilliant. But only difficulty is we will never ever come to know about it. This is a fact. The reason is simple. The distances are vast and it can never be covered in the span of times that you are talking about. Even to go to the next star, forget about the galaxy and all that I mentioned. It is light years away, 4 light years away, 25 light years away, hundreds of light years away. Even if you have a speed of light, you will take years together to reach. And no life existed in the very near galaxy, but if it is in the far galaxies, it is impossible for in the lifespan of the universe itself to ever to travel and reach. So we will survive and grow in technologies. Possibly some technologies will evolve for you to travel through space, curve, continuum to a shorter path. Until then, let us wait for the alien to come and watch us. But I can guarantee aliens are there and they are watching just behind the door. They are there looking at us and they are clapping. Oh, here is one fellow who understood that we are there.
Gopal Krishnan, quick one question. Very, very fast. We are running out of time. Yeah.
Okay, sir. I just want to narrate my association with the space research of the Government of India. In 1963, I was in a flying squadron here, and our aircraft was deputed to clear the sea area for the first Rohini rocket being fired from Tumba Equatorial Rocket Launching System.
Thank you.
Second, in 1973, when Admiral Kamath was here, and I was with his staff aviation officer, somebody from space station contacted me and wanted to carry out a very secret mission of carrying out a test firing from the aircraft from the Pune Air Force firing range. So I played a small part in arranging the firing range for the Air Force and carried out the trials by the spacer. That's what I want to tell you.
Thank you so much. Shankar Narayanan, Secretary for Felicitation. Shankar Narayanan will felicitate.
Okay, thank you all for that enthusiastic participation. Though we have loved to have more, due to paucity of time, we can't take more. Apologies. I invite Shankar Narayanan sir to offer felicitation.
Good evening, everyone present here. Distinguished Chief Guest, Dr. S. Somanath, respected Chairman Venugopal C. Govind, Vice Chairman Professor Ambad Vijay Kumar, Director Ramankutti, Chief Coordinator Programs Srimati Meena Vishwanathan, esteemed dignitaries on the dais, honored guests, colleagues, and dear friends. It's a tremendous honor to stand before you today as we gather to recognize and celebrate the extraordinary achievements of a visionary leader, Dr. S. Somanathan, Chairman of the ISRO. Dr. Somanathan's name has become synonymous with India's secular advancements in space exploration. And it is our privilege to express our heartfelt admiration and respect for his remarkable contributions. Under Dr. Somanath's guidance, ISRO has continued to reach new heights, carrying forward India's pioneering legacy in space science and exploration. His leadership, especially through recent landmark missions, to mention Chandrayaan-3, specifically has brought India to the forefront of global space research. The missions undertaken by him are not only technical achievements, but also symbols of national pride, showing the world that the dedication and resilience India can accomplish the extraordinary. What makes Dr. Somanath truly exceptional is not only his scientific prowess, but also his humility, dedication, and ability to inspire others. He embodies the spirit of discovery and has instilled this passion within countless young minds who now dream for reaching the stars. Through his mentorship and vision, he has made space exploration more accessible and has encouraged a generation to imagine the limitless possibilities that lie beyond our world. Today, we honor Dr. Somanath. We celebrate a leader whose contributions extend far beyond ISRO's achievements. He has helped to shape a brighter future for India, one in which our scientific aspirations know no bounds. Dr. Somanath, on behalf of everyone here, I extend our deepest gratitude and admiration. May you continue. May you continue to inspire, to lead with courage, and to guide India toward new frontiers in space and science. Congratulations on all your accomplishments, and thank you for being here with us today to share your wisdom to the young minds, which is yet another gesture that highlights your unwavering dedication to our nation. Thank you on behalf of all present here. Thank you, sir.
Thank you. Thank you, Shankar Narayan. Madam Meena Vishwanathan will propose the formal vote of thanks. You would like to leave at 4 o'clock, so please hurry up.
Okay, so we now request our chairman to honor our chief guest with the Ponnada and present a memento as a token of our appreciation. I request Meena ma'am to propose the vote of thanks.
Namaste to everyone present here. Esteemed Chief Guest, Dr. Somanath, and other dignitaries on the dais, invited guests, leaders of Bhavan's institutions, students, members of Bhavan's family, Namaste and Shubha Sayanam. This evening has been a very special one for all of us at Bhavan. Members in the audience, we've heard a distinguished son of India, the leader of hundreds of distinguished, dedicated scientists, the one and only chairman ISRO, Dr. Somanath, speak to us this evening. When India shines, as ISRO marks one stride after another, one win after another in the realm of moon and space programs, we, the common man and woman, are exalted, excited, and proud too. Thank you, Dr. Somanath, for addressing us on the topic, India's space missions. We really learned a lot from you. I place on record our thanks to our chairman, vice chairman, director, and secretary for leading us in the right direction at all times and for being here this evening. Special thanks to Dr. Vijay Kumar for getting Dr. Somanath here through his circle of friends and making today's lecture happen. Thank you, dear students, teachers, ladies and gentlemen present here this evening. The question and answer session was truly delightful. Special thanks to the principals and staff of Varuna, Erur, and Munshi for all the help rendered. The program committee members, thank you for the guidance and assistance rendered. The press, light and sound, staff, all staff of Bhavan TD Road, a very big thank you to you. Namaste and Dhanyavad.
As we celebrate the continuing success of ISRO, under the continuing chairmanship of the most outstanding, most ebullient, highly celebrated son of the soil, Dr. Somanathan, let us all give him, extend our appreciation by giving him a standing ovation.
with that, we come to the end of today's program. Thank you, sir. With that, we conclude. We now request you to remain standing for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे